Hi guys, welcome to Vedant Education Academy, where we solve math and engineering problems which are useful for graduate aptitude tests like GATE. This question on circuit analysis, I picked it from GATE 2018 paper. So we are going to solve this question. At the first glance, when you look at the circuit, it looks quite complicated, but I think we will get the right answer after I solve it. So first thing when you are going to solve such circuits is to not get intimidated. You have to solve it quick and you have to solve it correct. So let's see here. So we have the circuit and it's quite complex at the first glance. You can see there are resistances R1, R1, R2, and there is a potential across these 2 points which is 11 volts. And the question in the GATE 2018 paper Electronics and Communication was to find the current flowing through this circuit, which is I. We have to find I. So while solving such questions, first thing to remember is to look for the symmetry. So what I mean by symmetry, you can see from the circuit that many of the resistance are quite symmetric. There is R1 here, R1 here, R1 here, R1 here, and even R1 here. And you can see the R2 here, which is the same values, and R3 and R3 here. So the IITs which set these GATE questions are always going to set those questions which you can solve quickly if you apply your mind and the right technique. So in this case, what they are looking for, or what you have to identify once you see this, see the circuit, is to identify that it's quite symmetric. That's the first step. So the first step is identify the circuit is symmetric. Once you identify that, the next the logical step to follow is to find something called as equipotential points. So this is a standard technique while solving circuits. So now find the equipotential points which will drastically reduce the complex of this circuit. So in this circuit, what we can see here is there is current flowing through this circuit, and if you say this current is I1 and this here is I2, what you can realize from this symmetry is that I1 and I2 is same, because once the current flows here, it sees the same amount of resistance in this direction, and the I2 also says the same amount of resistance in this direction. So what you can see is I1 here is equal to I2. In that case, if you see if the current is coming from this end, you can also say that current flowing through this arm and this arm is similar. So that means we have equipotential points at two places in the circuit, which is here and here. These two are at equipotential, and here and here. Note that this and this is not equipotential, but this and this one is, and this one is not equipotential, but this and this one is. So what you can do is you can just remove the equipotential, the resistor which is connected to the equipotential points, because there is no current flowing through that, because the current here will be 0. So in these two resistance, so just remove this. Once you do this step, the solution is a piece of cake. So if I redraw this here, after removing the resistance between equipotential points, what you will get is something like this. So you have R1, and this is equipotential, so you just connect it. So this is R1 and this is R1, and then you have the equipotential points connected, and then you draw these other 4 resistances. If you just realize this, it and this R2 is also gone, so it means that all of these 4 resistance are in parallel. So what you can do is to redraw it so that you can understand exactly what's going on. And so this is R1, this is R3, this is R3 again, and this is R1. So we have redrawn this part like this, since these 2 resistances are gone, and then you have 2 resistances in parallel, which is R1 and R1 again. So now if you see, this is quite easy to solve. What you have here is all the resistance in parallel. So I'll just do a quick calculation in my mind. I'll first write down what are the values of these resistances. R1 is 1 ohm, R1 is 1 ohm, R1 is 1 ohm, R3 is 3 ohm, R3 is 3 ohm, and R1 is 1 ohm again. Here R1 is 1 and R1 is 1. So the equivalent resistance here is, since both of them are in parallel and same value, and the value is R1, so the equivalent resistance is R1 by 2, which is 1 by 2. And here also it's 1 by 2. You can do it quite quick, these two. And then if you look at here, I will just do these calculations in my mind. This and this are in parallel, R3 and that, so the resistance will be 3 by 2. Here the equivalent resistance is 3 by 2 and it's 1 by 2. So what you will get, equivalent circuit is it's 1 by 2, 1 by 2, 3 by 2, and it's 1 by 2. Now these two are in parallel, so it's quite easy. So the total value will be 1 by 2 plus 1 by 2 plus 3 by 2 into 1 by 2 divided 3 by 2 plus 1 by 2. So I'll just do a quick calculation, which is 1 plus, here it's 3 by 4, and it's 4 by 2. So if you do this, the calculation will go like this: 1 plus 3 by 4 into 3 by 4 into 2 by 4. So this is 1 plus it's gone, so 3 by 8, which is 11 by 8. So if you want to find I here, so the total resistance is 11 by 8 ohms. So the I will be 11 volts divided by 11 by 8, which is 8 amperes. So the I is 8 amperes. So this could be the right answer. I have not checked the answer key, but if you find anything wrong, please comment on it and I will make it correct. Please subscribe to our channel, which is the Vedant Education Academy, and we will solve more problems like this. Thanks.